Hello everyone. Today we are going to analyze this propped cantilever beam. In this beam there is a overhanging part BC. Its length is 3 meter. In the end of the overhanging, in the point C, there is a point load 30 kilonewton. The span AB is 4 meter long and there is no load in this span. From the point B, let us split the beam into two parts, AB and BC. So in the point B, there will be two reactions. Let us keep this reaction as RB1 and this reaction as RB2. To find the moment MB, we have to multiply the load 30 with the distance 3. When we do that, we will get 90. About the point B, this load is acting in the clockwise direction. So MB will be acting in the anti-clockwise direction in BC and in the clockwise direction in BA. To find RB, we have to add RB1 and RB2. We can easily find RB2. We know that the upward forces will be equal to the downward forces. So RB2 will be equal to 30. Now let us take AB and do the analysis and find RB1. We know that the upward deflection due to RB1 will be equal to the downward deflection due to the movement 90. In this case, we can use this expression. We know that EA is constant. We can eliminate that so that we will get this. Now from the point B and about the point A, we are going to find the moments and draw the bending moment diagrams. In this case, we have to follow left hand side rule. Clockwise will be negative and anti-clockwise will be positive. RB1 is acting in the anti-clockwise direction so that it will be positive and the distance is 4. RB1 into 4, we will get 4 RB1 and the diagram will be in the shape of a triangle. The moment 90 is acting in the clockwise direction so that it will be negative and the diagram will be in the shape of a rectangle. Now let us find area 1 x1 bar. We know that it is a triangle. We know the area formula of a triangle, half into BH. Here the breadth is 4 and the height is 4 RB1. So this is the area. We have to find the centroid distance x1 bar about the right side. The formula is 2 upon 3 into breadth. Here the breadth is 4. So it will be 2 upon 3 into 4. For area 1 x1 bar, we will get 64 upon 3 RB1. Now let us find area 2 x2 bar. We know that it is a rectangle. When we multiply 90 with 4, we will get the area. Let us find the centroid distance x2 bar. We can easily find the centroid distance for a rectangle. It lies in the center. When we divide the length 4 by 2, we will get the centroid distance. For area 2 x bar 2, we will get 720. In this expression, we have found both of them. Let us apply them. Finally, for RB1, we will get 33.75 kilonewton. In the span AB, there is no load. In this case, the values of RB1 and RA will be same, but they will be in the opposite directions. Since RB1 is acting in the upward direction, RA should be acting in the downward direction. Now let us take a moment about A and find MA. RB1 is acting in the anti-clockwise direction so that it will be positive and the distance is 4. The moment 90 is acting in the clockwise direction so that it will be negative. Let us assume that MA is acting in the clockwise direction, so it is also negative. Finally, for MA, we will get 45 kilonewton meter. Now let us take the overhanging part also. Now we can find RB. For that we have to add RB1 and RB2. When we add, we will get 63.75 kilonewton. Now using the right hand side rule, we can find the shear force values. Here you can see the shear force diagram. Using the right hand side rule, we can find the moment in the point A. In the point A, we have MA, which is acting in the clockwise direction, so that it will be positive. Using the left hand side rule, we can find the moment in the point B. The point load 30 is acting in the clockwise direction, so that it will be negative, and the distance is 3. Minus 30 into 3, we will get minus 90. We have found this already. We know that in the point C, the moment is 0. Here you can see the bending moment diagram. In this point, the bending moment becomes 0. In this point, we can make a section and find the distance. You can see that in that point, I have made a section at a distance of x from the point A. In this section, we can find the moment. We know that it is 0. Using that concept, we can find x.